All right, hello students. So we've got standard form that we were working on, and I just wanted to go over a few examples of doing a word problem and then using that to graph here. And when you're doing these sorts of standard form problems, you're always looking for two things that are combining to make a total. So I'm going to do problem 7 here, and then I'll skip down and do problem 10. So we have Charles and Jordan go grocery shopping, buying meat, hot dogs and hamburgers. They bought 8 packages of meat. And so when you approach a problem, you have to think, okay, what do I not know? What information is not given to me? Well, we know that they're buying hot dogs. We know they're buying hamburgers. We know the total is 8. But we don't know how many hot dogs and we don't know how many hamburgers. So that becomes your variables then. So let's just use x equals the number of hot dogs, y equals the number of hamburgers, and then all that we really know is that there are 8 of them total. So I know that x plus y, the hot dogs plus the hamburgers, has to make 8. Now I'm going to graph that. And when you graph that, the easiest way to graph it in most cases is to imagine you had all of one type of thing. So let's say I had no hot dogs, all hamburgers. How many did I buy? I bought 8 of them because there's a total of 8. And so we would represent that with a dot right here up at the y-intercept of 8 because 0 hot dogs, 8 hamburgers. Similarly, if I had all hot dogs and 0 hamburgers, I would have the point 8 comma 0 right over here on the x-intercept. Once you have 2 dots, you can just connect them with a straight line. And that straight line, what's useful about it is that straight line passes through all of the other combinations that work. So don't have perfect here on the computer screen, but the idea is that you could buy 0 and 8, or you could buy 1 and 7, or you could buy 2 and 6, or down here you could buy 8 of one and 0 of the other, and the line passes through all of the other possible combinations. I'm going to skip down and do number 10 now. Similar sort of situation, slightly different flavor here. Abby is going to the barbecue and she doesn't trust Charles and Jordan, so she's buying celery and hummus. And I want you to notice here, I actually know how many there are. What I don't know is the price. And so that's what my x and y are going to stand for. Here we go. Let's see. Oops. There we go. So x is going to be the cost of celery, and y will be the cost of hummus. And then we have 8 celery plus 3 hummus makes 24. In the previous example, I said, imagine you don't buy any hot dogs, then how many hamburgers? The same sort of idea. Imagine celery was free. Then you bought 3 packs of hummus for 24 bucks. That would mean that you have 0, 8. 3 times 8 makes 24. So I imagined the x was free, so there's no x's, and then 3 times 8 makes 24. Similarly, if I imagine that the hummus is for free, so the y value is 0, then I know that the x value has to be 3 because 24 divided by 8 is 3. And those become my y-intercept and my x-intercept right there. And there's the combinations that are in between. One thing that's a little bit interesting about this example is on the previous one, I could only have whole numbers. I couldn't buy 1.75 hot dogs and then 6.25 hamburgers. But here, decimals do make sense. So there's a lot more possible combinations here because we're talking about the cost of the celery and the cost of the hummus. So instead of it just being whole number values, there's quite a few more solutions there. So that's all the focus was for this class. In the next class, we'll work on converting from our standard form equations to slope-intercept form equations, which you really should be able to do already based on the graph that you're looking at, seeing the y-intercept is 8, and then you can draw a slope triangle. But that's for next class. Feel free to ask questions. Thanks for watching.